Good day, junior scientists! The title of our amazing activity today is the Color Spectrum Wheel Revisited. For today's objectives, you will be able to infer that number 1, light is composed of colors of different frequencies and wavelength. Number 2, the frequencies of the colors of light are inversely proportional to the wavelength. Number 3, the product of the frequency and the wavelength of the colors of light is a constant. And number 4, the arrangement of colors of light shows the hierarchy of the colors corresponding energy. And here are the materials that we need for this activity. Number 1, the color spectrum wheel pattern. Number 2, cardboard or folder. Number 3, a button fastener. Number 4, a glue or paste. Number 5, cutter or scissors. Reminder, please ask for assistance from your parents or guardian in using the scissor or cutter. And here's what you are going to do. First, paste the color spectrum wheel pattern in a cardboard or folder. Second, cut the two art files that make up the wheel. Third, cut along the lines drawn on the top wheel. Cut the two sides as shown. The small window near the center of the wheel should be completely cut out and removed. Fourth, punch a hole at the center of the two wheels. You may use a button fastener to secure the two wheels together, one on top of the other, but they should be free to rotate relative to each other. Fifth, when you see a region of the color spectrum show up in the open window and the wavelength, frequency, energy that correspond to the region showing up under the flaps, then you know that you have done it right. That's amazing! In this part, you will do the following. Number 1, try out your color spectrum wheel by positioning the innermost of the flaps on the color spectrum. This will simultaneously position the other flaps to wavelength, frequency, and energy. Number 2, turn the upper wheel and observe the combinations. Number 3, fill in the table with the corresponding combination you have observed using your spectrum color wheel. Column 1 contains the colors. You will identify the frequency of each color and write it in column 2. Wavelength of each color will be written in column 3. you need to multiply the frequency and wavelength for column 4. Lastly, you will indicate the energy of the specific color. Number 4, you will need to convert the equivalents of frequencies to hertz, the equivalent wavelength to meters, and joule to electrovolt. Note the following equivalents. Take note that tera, or capital T, is a prefix for 10 to the power of 12. 1 terahertz is equivalent to 1 times 10 to the power of 12 hertz. Nano, or small letter n, is a prefix equivalent to 10 to the power of negative 9. 1 nanometer is equivalent to 1 times 10 to the power of negative 9 meter. 1 electron volt, on the other hand, is equivalent to 1.6 times 10 to the power of negative 19 joule. Answer also the questions found in your book. Question number 16. Which color registered the highest frequency? Shortest wavelength. Question number 17. Which color registered the lowest frequency? Longest wavelength. Question number 18. What did you observe about the wavelengths and frequencies of the different colors of light? Question number 19. What did you observe about the products of frequencies and wavelength? Question number 20. Do the frequencies of the colors of light increase from red to violet? Question number 21. What did you observe about the corresponding energies from red to violet? And last, question number 22. How is frequency related to energy of colors of light? That would be all for today. I am Teacher Gab saying, have an amazing day.